Welcome to the session. Greeting of the day. In today's class, we are going to talk about the various dies which we are using for doing the sheet metal operations. In earlier classes, we have seen the various sheet metal operations of blanking, piercing, spinning, coining, those things, stitch forming, such various methods of bending, all we have seen. We are doing those things using some various die operations such as a progressive die, compound die and a transfer dies. The name says everything, a progressive die, compound die, a transfer. It is the process which is going to travel between one station to the another station. So that is called as a transverse die. We will see one by one. Number one, I have taken as a progressive die, parts requiring multiple operations, such as we have done some blanking and piercing operations, 2 holes, and one we have taken as part with what we need, and one we have taken as a scrap items. So likewise, multiple operations such as punching, blanking, notching operations are made at high production rate. In the progressive die, multiple operations are done. Progressive means we are processing more. Multiple operations are done at one station. A single setup, single die, single punch, but operations multiplied. Not for a single die, single operations are not did. It is progressing too. Punching and blankings are done. So therefore, we are naming this as a progressive die where we are doing multiple operations at high production rate. The sheet metal is fed through the coiled strip and different operations is performed at a same station. So this point is important. On end of the same station with each stroke. Same station, single stroke, multiple operations. You see here, in this setup we have a punch, a die and strip. This yellow color strip here. This yellow color is a sheet metal which we are going to punch. What happens? This contains 2 punches. Here, 1 punch we have, and 1 more we have here. So this the large one I am calling this as a blanking punch, and the small one I am calling this as a piercing punch. What happens? I have kept the strip inside. It means I kept the sheet inside. And I am going to do a single stroke operation. Each single stroke operation, when I am doing the forces applied over the sheet, this blanking punch will go for the blanking operations, and we are getting one product here. And this at the same time, on the same stroke, smaller punch will going to have a force there, and we are going to get a piercing product there. So this multiple operations takes place such as blanking and piercing on a single stroke. That is also at high production rate. So that is what I am naming this as a progressive die. So this is how it looks. So some animated image how it can be utilized. So blanking and piercing operations are done through progressive die. Next I am coming to the compound die. The next several operations on the same strip, several operations to be done on the same strip, on the same sheet, by performed in 1 stroke with the compound die in 1 station. This is also we are doing a 1 stroke, 1 station, but multiple operations one after the other. A compound die, one process has been done, a blanking has been done, then the blanking sheet has been kept inside again on the same, and we are punching for making the cup drawing operations, such as we can able to do. These operations are usually limited to relatively simple sharing because they are somewhat slow and the dies are more expensive. Not like blanking piercing, we are using a little bit a large simple product, not that much heavy designs. Therefore, when the die size is increasing, obviously cost also is getting increased. So for individual shearing operations, we can individual shearing operations, one stroke, one shearing. But the same piece again has been blank displacement has been taken. First we have taken on punching actions, and on the punching actions we are getting one product, and I am keeping the same product again there, and I am doing again punching for the drawing operation which forms a cup when we are changing the die. So accordingly on the machine setup we should alter it, and we are componently we are using compound, multiple compound we are using there. There the multiple operation a single stroke. But here on a single stroke one operation did, but multiple operation can be did by changing the dies. So I am telling this as a compound die. This is one of the type of die useful for making the cup drawing operations. Next I am coming to the transverse die, otherwise called as a combination die. You see, in transfer die setup, the sheet metal undergoes a different operations at different stations. We have, this is one station and this is one station, and here we are going to do one operation, and the same thing strip has been moved here, and again we are doing the another operation. So such how the operation will extend itself to transfer from one station to another station, one station to another station to perform the task. That is what I am naming. So the sheet metal undergoes a different operation. Here may be one blanking operation, here may be one piercing operations, are at different stations which are arranged along a straight line, which is arranged along a straight line, which is arranged along a straight line, and therefore we can able to do blanking and piercing operations. It may be not on a straight line, it may be a circular also. A set of this image shows you a transfer type operations where number of punches are there here. Number of punches are there. The strip has to come, the die has to move from here. This is the die, it is going to move, and the various punching mechanisms will take over on the setup. So transverse die, multiple operations. How to select this? Press selection for the sheet metal forming operation depends on how the selection of this various progressive dies, compound dies, how to select this various forming operations, bending and squeezing according to the requirements. So some points we have to remember. Type of forming operations and a die and a tooling required. That is one point. Right? And then one. The press selection of the sheet metal forming operation depends on the several factors of the size and shape of the workpiece, how the size, what size we need, whether the D or D by 2 or greater than D by 2, what is the size and shape, circular object or what shape it is. According to that the process will differ, according to that die shape will differ, according to the punching differ. Here you see, here the punch is different, here the punch is flat, here the punch is the circle, semicircles. So likewise it is differs, the product shape and size differs according to the punch and die also is differing. The length of the stroke, how far it is lengthily we have to give. Stroke per minute, how many strokes per minute. Right? Speed, stroke slowly we are giving, workload is not there, force is not there, how the forming will occur. Therefore, how many strokes per minute, how fast we should give. How speed and shot height, from where we have to put the speed limits. Then the force created. We are putting from here fast, the speed is not created. When the same is putting from here, the speed is created. So such how many slides are there, maximum force requirement, how this maximum force requirement is related to speed and shot height. So these are all interrelated points. Type of controls, die changing features. From one die to another die we have to change for the different operations. We are doing the compound die operations. One blanking has been done, die has been changed, and simultaneously we are doing the deep drawing operations on the compound die. So such the die changing features, how it is to be done. So depending upon that, at last we have the safety features also. So types of press frames. We have a basic C frames, wide design frames, Adjustable beds. Beds can be adjusted up and down. Up and down we can adjust. Or open backs, pillars. We have seen tensile testing machine, UTM machines we have seen that are not belong to this pillar type machine setups. So likewise other double column setups. So that is double column setups are useful for this gravity punching method, gravity forging process, drop forging process. Those are not, this belongs to double column machine setups. So likewise it is available. Sheet metal and pet metal products applications where we are using. We are using in the automobile and trucks, aeroplanes, railway cars, locomotives, frames, constructions, small and large applications of various automobiles, car productions, office furnitures and computers and office equipment. So this is general, I have given very limitedly. But we have more process are there, handling, door handles, all things, frames of homes, all these things can be done by the sheet metal forming process. So advantages, it may also will get high strengths, good dimensional accuracies, good surface finishes are there. So this gives the good strengthening factors also. So relatively low cost for large quantities we need large quantities and economical mass productions operations are possible. Mass productions are done by using these transfer dies. Mass production done by using these transfer dies, and it will be helpful for immediately next process we can able to move. So what are the various accessories tools we are using here? We are using the steel tools, which is, you know this, generally for sheet metal we have to mark the length, the dimensions, protractors, the angles, those things we should mark, and then only we are going for blanking, tracing, deep drawing, cutting, bending operations and all. Before marking, just like that we can't able to take, just like that we can't able to, some dimensions required. If the dimensions required, the marking scales and tools required to do that job. So it is used to set out the dimensions. Yes, tri-square used to make some testing angles, maybe it's like that of 90 degrees. And scribbers used to scribe or mark the lines. Mark not with pencils, scribbles are needed there, which is steel. We should mark, the punch should be visible. So dividers used to marking circles, arcs, laying. So this parts all we know. We have day-to-day life we are using this. So some of the instruments which we are using for creating of this sheet metal operations: hacksaws, files, scribbers, hammers, spring device, squares, bench vices. These are we are generally using in the workshops, which belongs to utilized for this all sheet metal working operations. And some other cutting tools, marking tools we have seen. So some cutting tools we have a straight snip and curved snips are there. They have a straight jaws. We have a straight jaws which is used for the straight line cut. We know this. And the curved snippers. So we have the curved snippers which is useful for making the circular cuts. So circular cuts we need. At the time we are using curved snips. Straight line cutting we are using the Schneidler snippers. So such others. And then a mallet, hammering treatments we have to do. These are all generally we are using the casting process. So such can able to do this. It is a wooden headed hammer of around a rectangular cross section. The striking face is made up of a flat and to the work. So and for the work we can able to use a mallet. Different designs are there, end-to-end connected, hammering process, lightly casting, removal of the patterns. So such cases we are using those things. So some of the tools we should understand. So the summary. In today's class we have talked about various sheet metal operations. Sheet metal operations such as various rubber pad forming, then explosive forming, right, and hydro fluid forming, so some various and also we have seen about various press press and press tools such as compound die, progressive die, right, and transfer die. So these are things we have seen in the today's class. So total summary, we have seen about in general about this entire production technology process. We have taken about 5 modules of 4 to 5 subject wise, category wise we have taken. On that we have seen about the first one as a casting of process, and also we have seen the second one of other casting process, such as a centrifugal casting. So some 2 to 3 types we have seen there. And then we have seen about the important topic of welding, like fusion welding and friction, pressure welding. It means non-pressure welding, pressure welding. Some other process also we have seen in the 3rd unit. And then in the 4th unit we have done about bulk metal deformations, such as rolling, forging, and extrusions. And then now we are in this 5th we have seen about this sheet metal deformations. Sheet metal deformations of bending, blanking, and then coining, stretch forming, and we have, these are the various done in the production technology. So importantly in the welding we have concentrated more various types we have seen there. Fusion welding will contain here about this is SMAW, and then about the SAW, submerged arc welding process, then about the TIG welding process, MIG welding process, electroslag welding process, plasma arc welding process. So such various process also we have seen in the fusion welding. And in the friction pressurized welding, you see, this will take a lead here. In the pressurized welding process, we have seen about friction welding, friction, stir welding, resistance welding, and forge welding, thermit welding. This thermit welding comes under fusion, not in pressure. It is also one of the type we have seen. Thermit welding process and some other few parts of heat affected zones. So some other parts of heat affected zones, welding defects. Here we have seen about procedure and casting defects also we have seen. Casting defects. So importantly, these are the various topics we have covered in our subject of production technology. Into the 5 units we have covered up to now. Thank you.